Welcome to today's video where we break down the definition of data analysis in the simplest and most practical way. Whether you're new to data or looking to sharpen your skills, this video will set a strong foundation for your data journey. Now let's dive into the video.
Definition of data analysis. What is data analysis? What can we define data analysis to be? Now, I define data analysis as a process. Please note that word. Data analysis, I define data analysis as a process. Data analysis is the process. So it's not something that is rigid. It's not something that is static. It's a process. There are patterns, there are process, there are methodology. There are systems to which we use in order to analyze data. So data analysis is the process of systematically. You can see that I purposely bold systematically. Why? Because it's something that is not done haphazardly. It's not just you come anyhow, you just say, okay, this is what this will be. No, there should be a pattern, there should be a system, there should be a structure to which your argument, to which your statement, to which your hypothesis, your prediction, your inference, or your statement stands. So data analysis is not just coming to do a guesswork, coming to do a hearsay. It's something that is systematically done. So what is that? Is the process of systematically first collecting. There should be something we will use in order to make certain inferences, certain decisions. So we need to first of all collect it. And what is that we are collecting? Data. So it's the process of systematically collecting data. And when I say, why should we systematically collect data? Just go and collect data now. No. In analysis, data should be well represented so that the decision will be what we so that the decision is what we can say is not biased. So as to have a very unbiased decision. So we need to properly collect our data and ensure that our data represents the entire population. We are still getting to that. But systematically, we ensure that we collect it effectively. For example, if we want to check the average performance of Nigerian students in the last concluded WAEC examination, we can come to say, okay, we are collecting the data from all the states, from one of the states. Let's say, like in Osun now, and we just collect data from Osun State, and we get the average performance, and we use the average performance of students in Osun State to judge all the students in Nigeria. That data collection is not well represented. So it's not done effectively, it's not done systematically. So what can we do? We can come to Osun State, collect some samples, go to all the states, collect sample results from different local governments of the state represented, and then bring it together and check the average performance. And from there, we can say that the average performance of Nigerian students is above average score and stuff like that. That is when we can say the data is well represented, that the data we collected represent all the states and regions of the Federal Republic of Nigeria. So data analysis is the process of systematically collecting. And when we collect, organize the data effectively. In organizing, we put it in a spreadsheet, organize it, check it, what are the things that are needed, we input, what are the things that are not needed, we remove it. So it's a process of systematically collecting, organizing, and analyzing. You organize, you analyze. Some might say, okay, why do you put analysis? That's part of the process as well. They interpret and present. Now, ladies and gentlemen, I need to state this to you, that interpreting data analysis, one of the things that makes you a core data analyst, in fact, one of the things that makes you a true data analyst is the ability to interpret your data. The ability to interpret and present. Some of us can use Excel to analyze, use SPSS, use Python, use R, use this. But when we get the result, when the output comes, we are confused. We don't really know what those outputs stands for. We don't really know what they mean. We don't really know how to interpret that output and use it to make informed decisions, and use it to uncover insights, and use it to uncover trends. So what truly makes you a data analyst is your ability to interpret and present data. Why I pause a bit is for this to digest. What really makes you a data analyst, that you go out and flout yourself that I'm an analyst, is your ability to interpret your result. So when you collect data, organize it, what we call data management, data organization, and then you analyze that data. and the result you got, the output that you got, the ability for you to interpret it, understand their meanings, and interpret the output, the result, and present it in such a way that is decision making, in such a way that you predict outcomes. That is what fully makes you a data analyst. So having established that, we now conclude. Let me read it all through now. Data analysis is the process of systematically collecting, organizing, analyzing, interpreting, and presenting data. For what purpose? For the purpose to uncover meaningful patterns, so that we can predict trends and insights for decision making. Now, having established that, we said it involves applying statistical, please get that, involves applying statistical, mathematical, and computational techniques to raw data. What statistical means, we need some statistical understanding. We are not going to be saying you need to learn statistics. No, we are not saying you need to immerse yourself in statistics. No, there are basic statistics you need to know. There are basic statistics you have to know. That's what is required. Basic statistics, your average, your mean, your standard deviation, your variance, your mean square, your standard error of mean, all those basic statistics. We are not talking about you going to gamma laws and all that. No. Those basic computation. The mathematical is your ability to understand basic maths, basic arithmetics, basic laws of some we call it pendants, some call it board mass. That basic law, the Boolean algebra, the mathematics of 0 and 1, the probabilities in 0 and 1, the basic maths, then computational techniques, the ability to use softwares, the ability to use softwares in other techniques to raw data. Raw data is data that has not been used. That's raw data that has not, raw data is what has been used. You are using it for a purpose. You haven't transformed it. You haven't analyzed it. That's raw data. So to raw data, to convert it into actionable information that supports decision making, problem solving, and forecasting. This is the definition of data analysis.
Now you understand what data analysis really means and why it's so important. In our next video, we'll explore the types of data analysis and how they are used in real-world decision making. Don't forget to like, share, and subscribe so you don't miss it.